Hello everyone, welcome to the channel and to the series of solving previous year questions for class 10th maths. In this video, we will be solving previous year questions for polynomials class 10th, and all the questions we will be solving are the questions from the CBSE board papers for session 2023-24, that is last year. I have analyzed all the previous year papers of CBSE, all the 5 sets of paper as well as the compartment paper of the last year and sort out these questions for you. And this video will be very helpful for you as we are going to solve the exact questions appear in the board exams last year. And the plus point is you will get it. The plus point is you can easily get the list of questions chapter wise along with the detailed solution of it that has been in the CBSE board exam actual paper, the final paper. As the trend of last year, this chapter, polynomials, has a weightage of 4 to 5 marks. And the questions from this chapter comes in a combination of MCQs, 2 markers or 3 markers. I have also seen 2 assertion and reasoning questions from this chapter as well. That also we are going to solve in this video. So this video is going to be very important for you as you can. This video is going to be very important for all those who are going to appear in the board exams next year. So let's begin the video. In this video, we'll be solving a total of 27 questions with the combination of MCQs, assertion reason, 2 markers and 3 markers. Okay, so let's begin. So let's start solving the questions. Also one more point, these are the questions of last year board exam paper mathematics standard. So this video is especially for all those who opt standard maths in their board exam. The video for basic, the same kind of video for basic mathematics will be releasing soon. So let's begin with question number 1. This is an MCQ type question, multiple choice question. So the question says as, if alpha and beta are the zeros of polynomial 2x square plus 5x plus 1, the value of alpha plus beta plus 3 alpha beta is. So let's see. So alpha and beta are the zeros of the polynomial 2x square plus 5x plus 1. So we know that, and we need to find the value of alpha plus beta plus 3 alpha beta. And we know that alpha beta, that is the sum of polynomials, is minus b by a. So here minus b by a is minus 5 by 2 plus 3 as it is. We know that alpha beta is product of two zeros of the polynomial, which is equals to c by a. So we got minus 5 by 2 plus 3 by 2, which is equals to minus 2 by 2, which is equals to minus 1. So for this question, the correct answer is D, option D. Now, this is the question number 2. This question says that if the sum of the zeros of the polynomial px square minus k root 2 x plus 1 is root 2, the value of k is. So what is the value of k we need to find, and we have given the value of sum of zeros. So sum of zeros is, we know, minus b by a, so which is equals to k by root 2, and the minus got cancelled out. Upon a is 2. So this value is equals to k, we got k root 2 upon 2 is equals to root 2. So from this we got 2 root 2. So k is equals to 2 root 2 upon root 2. Root 2 got cancelled by root 2 and k is equals to 2. So the correct answer for this is option number B. Let's continue the video now with question number 3. The question number 3 says that the zeros of the polynomial x square plus px plus q are twice the zeros of polynomial 4x square minus 5, 5x minus 6, and we are asked to find the value of p. So the zeros of the polynomial x square plus 4 plus px plus q, the zeros of this polynomial are twice the zeros of this polynomial 4x square minus 5 minus 6. So first of all, we'll find the zeros of this polynomial. So we can easily get the sum of the zeros of this polynomial. As we know that alpha plus beta is minus b by a, minus b by a, minus minus when multiplied becomes plus, and we got 5 by 4. And what the question, and let the alpha dash and beta dash be the zeros of this polynomial. Okay, so alpha dash and beta dash. So alpha dash is 2 alpha and beta dash is 2 beta. Okay, so 2 alpha plus 2 beta will be the sum of the zeros of this polynomial. Now we take 2 as common, alpha plus beta, and we know that the value of alpha plus beta is 5 by 4. So 2, 5 by 4, 2 ones are 2, 2 twos are 4. So we get 5 by 2. So, and this is the sum of the zeros of the polynomial, as the zeros of polynomial of this polynomial, that is x square plus px plus q is twice the zeros of this polynomial. So the sum is equals to minus b by a. So this value is equals to minus b by a. The value of a is here 1. So from this we got the value of p is minus 5 by 2. The value of p is minus 5 by 2, and when you matches the option, the correct answer is option number A, that is minus 5 by 2. Now continue with question number 4. This again an MCQ type question. The question says that if the sum of the and the product of zeros of the quadratic polynomial are 2 root 3 and minus 3 respectively, these, so sum of the sum of zeros of polynomial, let's take the zeros of polynomial as alpha and beta. The sum is 2 root 3 and the product is alpha beta is equals to minus 3. We need to find the quadratic polynomial. So we know that rule as x square minus alpha plus beta x plus alpha beta will be the quadratic equation. So x square minus alpha beta. So we have the value of alpha beta as 2 root 3 x and alpha beta is minus 3. When minus and plus get multiplied, it become minus. So we got minus 3. So the quadratic polynomial we get is x square minus 2 root 3 x minus 3. And when we matches the option, we got option number C as the correct answer. Option number C is the correct answer. The question number 5 is the next question. The question says that if alpha and beta are the zeros of the polynomial is 5x square plus 3x minus 7, and we need to find the value of 1 by alpha plus 1 by beta. So to find this value 1 by alpha plus 1 by beta, first we take the LCM. We got beta upon alpha beta and alpha upon alpha beta, which can be written as alpha plus beta upon alpha beta. And we have given the quadratic equation. From this equation, we can easily get the values of alpha plus beta and alpha beta. From this equation, we get the sum of zeros is alpha plus beta, which is equals to minus b by a, and product of zeros, that is alpha beta, is c by a, that is minus 7 by 5. When we put these two values in our equation, we got minus 3 by 5 upon minus 7 by 5. And whenever we have double fraction, the method of solving is 3 by 5, and the denominator which has double fraction got reciprocal. 5 got cancelled by 5 and minus sign got cancelled by the minus sign in the denominator. So we got 3 by 7. Here 3 by 7 is option number C. The correct answer for this question is option number C, that is 3 by 7. Here comes the next question, that is question number 6. The question number 6 says that if alpha and beta are the zeros of the polynomial is 2x square minus 9x plus 5, and we are asked to find the value of alpha square plus beta square. So in these type of question, the major mistake students make is they assume alpha plus beta whole square equals to alpha square plus beta square, which is absolutely incorrect. This value is not at all equal. For the reason I'm telling you, see, when we open this identity alpha plus beta whole square, it is alpha square plus beta square plus 2 alpha beta. And when you are equating these two values, you are missing out this 2 alpha beta, which make your assumption absolutely incorrect, and got and you will get the incorrect answer. So to get this value, what we will do, we'll use this identity only. If alpha plus beta whole square is equals to alpha square plus beta square plus 2 alpha beta, and we are asked to find this value. So alpha plus beta whole square minus 2 alpha beta will be equals to alpha square plus beta square, and we can easily get these two values as the sum of zeros of polynomial and the product of zeros of polynomial from the polynomial given to us. So from the polynomial given to us, the sum of the zeros of polynomial is minus b by a minus 9 minus upon 2, which is equals to 9 by 2, which is the sum of the polynomial, and the product of polynomial is c by, which is equals to 5 by 2. When we put these two values in this equation, we get 9 by 2 whole square minus 2 5 by 2. On solving it, we got 81 by 4 minus 10 by 2. We take the LCM this side. I'm solving it in the bottom portion. 81 by 4 minus 20 by 4, and the value is 61 by 4, which is here option number B, that is 61 by 4. That is the correct answer for this question. The question number 7. The question number 7 is one of the tricky questions that appeared in last year board examination in the session 23-24, and this is an important question, so we'll be marking it with an star. It is a very important question. Many of the students solve it incorrectly. So here I'm telling you the correct method how to solve it. So the question says that if alpha and beta are the, and given that the condition is alpha is greater than beta are the zeros of the polynomial is minus x square plus 8x plus 9, and we are asked to find the value, then alpha minus beta is equals to. Okay, so first of all, the steps will go to follow to solve this question. We'll write the polynomial given to us, and what values we can interpret from this. We can get the values of alpha plus beta, that is minus b by a minus 8 by minus 1 upon, that is equals to 8, and the product the polynomial, that is c by a 9 by minus 1, that is minus 9. We got these two values from the quadratic polynomial given to us now, and we are asked to find the value of alpha minus beta. So alpha minus beta can be calculated from this identity alpha minus beta whole square, okay, which is equals to, we know that identity alpha square, this alpha can be interpreted as a and beta can be as b, as we have known this identity since so long. Alpha square plus beta square minus 2 alpha beta. If I'll add and subtract alpha and 2 alpha beta in this same equation, then how it will become? And using another colored pen, so you won't get any kind of confusion, and write this to alpha beta same. So this value on solving will become 0, eventually will become 0, but here it is very beneficial for us. So this can be rewritten even as n. On taking this, it becomes alpha plus beta whole square, and this value becomes 4 alpha beta, which is equals to alpha minus beta whole square, and we are asked to find this value alpha minus beta. On taking under root, we could solve it. So we have alpha plus beta is 8, so 8 square minus 4, alpha beta is minus 9, 8 square is 64, the value when minus is multiplied with another minus, it become a positive number and we get plus 36. So 100 is equals to alpha minus beta whole square. Here also many of the students make a huge mistake, not a huge, I could call it a silly mistake. Alpha plus beta whole square is equals to root 2. So we have to put root 2 on both the sides and we got this value. And the point to remember here is whenever any value comes out of a root, it comes with a plus and a minus both in it. So root under root of 100 is 10. That is not only 10 but plus minus 10. And many of the students in hurry or in stress of the examination, you put it as only positive 10, which makes your answer absolutely incorrect. So the correct answer for this question is plus minus 10. So that's why I told you it's an important question, because in many steps you have to keep a lots of things in your mind, and if you slip any of them, your answer will be incorrect. The next question. This question can either be put in the domain of quadratics or in the polynomials. But I have taken it in this chapter, polynomials. So let's solve it. The question says that if polynomial px is given by px is given to us, that is x square minus 5x plus 6, and we are asked to find the value of p1 and pb, or p1 plus p4, sorry, p4. So first we'll find the value of p1, x square minus 5x plus 6, and at the place of x in this equation we will put 1. So 1 square minus 5 into 1 plus 6, it will become 1 minus 5 plus 6, that is equals to 7 minus 5, 2. Now we are asked to find p4. So now here the value is 4. So what we'll do, at every place of x in the equation, we'll put the value of x as 4. X square minus 4x plus 6. 4 square minus 5 into 4 plus 6. 4 square is 16 minus 20 plus 6, that is 22 minus 20, which is equals to 2. And we are asked to find the value of p1 plus p4, which is equals to 2 plus 2, that is 4. So the answer for this question is option number B, 4. The next question is question number 9. The question number 9 says that if alpha and beta are the zeros of polynomial, the polynomial px is given to us as kx square minus 3x plus 45, and alpha plus beta is equals to alpha beta, then we are asked to find the value of k for this question. So this equation is given to us, that is alpha plus beta is equals to alpha beta kx square minus 30x plus 45k. So alpha plus beta, from this equation we got minus b by a equals to c by a. So we got positive 30 upon k equals to 45k by k. This k got cancelled and we got 35 is equals to 45k. The value of k is 30 by 45. On simplification, when we divide the both numerator and denominator by 5, we got 6 by 9. On dividing it by 3, we got 2 by 3. So value of k is 2 by 3. When we matches the option number D is correct, that is 2 by 3. The next question is question number 10. The question number 10 says that the ratio of the sum of the zeros of sum and the product of roots of the quadratic equation. So we need to find the ratio of sum of the zeros of quadratic equation to product of zeros of the quadratic equation. So we are asked to find as alpha plus beta upon alpha beta. We'll simply find these values and put here. Alpha plus beta is minus b by a, that is minus 6 minus plus it is 6 by 5, and alpha beta is c by a, that is this alpha plus beta, and this is alpha beta, that is c by a, 21 by 5. So 6 by 5 upon 21 by 5, in the the equations of these double fractions, the denominator got reciprocal. The 5 got cancelled by 5, that is 6 by 21. On dividing the both numerator and denominator by 3, we got 2:7 is the answer. 2:7. When you matches the option number B is correct, that is 2:7 as we have solved. Till now we have solved 10 MCQ type question which appeared in the board examination for the session 23-24. They were the exact question which appeared in the paper, all 5 sets of the paper as well as the compartment paper. Now we are solving 2 marker questions. In last session there were only two marker question. I mean, this was the question number 1 and this was the second question combined with all of the 5 set as well as the compartment exam. So the probability of coming 2 marker question from this chapter is less, as I have seen only 2 questions which were 2 marker. Anyways, let's solve it. So the 2 marker question, this question says that if alpha and beta are the zeros of the polynomial, that is px square, which is equals to 5x square minus 6 plus 1, and we have to find the value of alpha plus alpha beta, and this is a very easy question. Let's solve it together. Px is 5x square minus 6x plus 1, and we are asked to find alpha plus alpha beta. So alpha plus beta is minus b by a, minus got plus alpha beta, that is 1 by 5, so 6 by 5 plus 1 by 5, we got 7 by 5, that is the value, and that's it. So it's a very easy question. Let's continue with the next question. The next question says that if alpha and beta are the zeros of quadratic polynomial, that the polynomial is px, which is equals to x square minus 5x plus 4, and we are asked to find the value of 1 by alpha plus 1 by beta minus 2 alpha beta. So first of all, we will find the value of alpha plus beta and alpha beta from the polynomial px given to us. Okay, it's a minus 5x square minus 5x plus 4, and alpha plus beta from this equation is positive 5, as minus and minus when multiplied become positive, and alpha beta, that is c by a, will become positive 4. So on solving this equation, 1 by alpha plus 1 by beta minus 2 alpha beta. First of all, we'll take the LCM here. Beta upon alpha beta plus alpha upon alpha beta minus 2 alpha beta. It will become alpha plus beta upon alpha beta minus 2 alpha beta. I'm putting the values on the side. So alpha plus beta is 5 and alpha beta is 4 minus 2 alpha beta is again 4. So it is 5 by 4 minus 8, which is equals to 5 minus 32 upon 4 is equals to minus 27 upon 4. That is the value of this equation asked in the question, that is minus 27 upon 4. These were the only 2 marker questions asked in the last year paper, and there are many 3 marker questions. So the probability of coming 3 marker question this year are more than a 2 marker question. So we will solve those 3 marker questions as well as in this video. So stay tuned till the end of the video. So let's start solving 3 marker questions, and I hope this video is very helpful for us, as you can get the list of all the questions which appeared in last year board examination to you with detailed solution of it. So let's continue with it. The question number 16 says that if alpha and beta are the zeros of the polynomial px, which is x square minus k plus 5x plus 5k plus 1, such that alpha plus beta is equals to alpha beta upon 3. Okay, so from this polynomial px, we can get the value of x square minus k plus 5x plus 5k plus 1. We got the value of alpha beta, which is minus b by a, alpha plus beta upon alpha beta upon 3. So alpha beta is minus b by a, and we can see that the value of a here is 1. And this minus, when multiplied with another minus, get turn into a plus. So k plus 5 is equals to alpha beta upon 3. Alpha beta is c by a. Again, the a is 1, so we don't need to worry about the denominator right now. 5k plus 1 upon 3. So on taking this k, this 3 here in multiplication, on solving this equation, we got this value. On multiplying the 3 with k, it becomes 3k plus 15 equals to 5k plus 1. So on resolving it, 15 minus 1 is equals to 5k minus 3k. 15 minus 1 is 14, and 3k minus 5k minus 3k is 2k. So k is equals to 7, and that's the solution of this question. The value of k is 7, and that was asked to us to solve. Okay, let's continue with another question. It is also a 3-marker question. Given that find a quadratic polynomial whose sum of the zeros is 8 and the difference of the zeros is 2. So let's assume first of all the two zeros be. Let the zeros be alpha and beta, as we are taking the same assumption from the starting of the chapter. So we are asked that alpha plus beta is 8 and alpha minus beta is 2. And here we got two linear equation, and that can be solved by any of the method: substitution, elimination, cross multiplication. And the easiest one we can get here is the elimination method. What we will do, we'll add both of these equation number 1 and equation number 2. On adding these two equations, this become 1 alpha plus 1 alpha, 2 alpha plus alpha minus alpha become, plus beta minus beta becomes 0. So we don't need to write anything. And 8 plus 2 is 10. Alpha is equals to 5. As soon we get this value of alpha equals to 5, we can put this alpha here in the equation. Alpha plus beta is equals to 8. Alpha as 5 plus beta equals to 8, and beta is equals to 3. Now we are asked to find the quadratic polynomial. And we know that how we can find the quadratic polynomial is x square minus alpha plus beta x plus alpha beta x square plus 5 plus 3 x plus 5 into 3 x square. 5 plus 3 is 8, so 8x, and 5 into 3 is 15. So our answer is x square minus 8x plus 15. I hope you can easily understand all the questions we have solved till now. Let's solve some more questions now. Our next question is, this question says that if alpha and beta are the zeros of the polynomial 3x square minus 13 minus 10, and we are asked to find the value of 3 alpha plus 1 and multiplied with 3 beta plus 1. So first of all, we'll simplify what is being asked to us. So how to simplify is, I will tell you this as well in detail. So this value first multiply with this value, and this value got multiplied with this. Same here, this we can multiply it. So we got 3 alpha into 3 beta, that is 9 alpha beta, plus same as it is 3 alpha into 1 is again 3 alpha. 1 into 3 beta is 3 beta, and 1 into 1 is 1. So on further simplification of this equation, we get 9 alpha beta plus 3 we took in common, alpha plus beta plus 1. Now it's become very easier for you to now solve it further. You can pause the video and solve it by yourself, and then again check your answer by replaying the video. We can get the value of alpha beta from the polynomial, and also the value of alpha plus beta from the polynomial. So the polynomial is 3x square minus 13x plus 10. From this, the value of alpha plus beta, that is minus b by a, So when minus got multiplied with minus become positive, that is 13 by 3, and alpha beta by c by a minus 10 by 3. On substituting these two values in the equation, we solve 9 alpha plus beta minus 10 by 3 plus 3 alpha beta 13 by 3 plus 1. On solving it, 3 ones are 3, 3 threes are 9, 3 got cancelled by 3, minus 30 plus 13 plus 1. We got minus 30 plus 14, which is equals to minus 16. That's the solution of this question. I hope you understand it. Let's continue with another question. This question says that if alpha and beta are the zeros of quadratic polynomial, the polynomial is 6x square plus 11x minus 10, and we are asked to find the value of 1 by alpha, alpha by beta plus beta by alpha. So first we will simplify this expression. Alpha plus upon beta plus beta upon alpha. On taking LCM, we got alpha square plus beta square upon alpha beta. Now solve this value. What we need to do, we will use this identity as alpha plus beta whole square equals to alpha square plus beta square plus 2 alpha beta. And if you assume both the values alpha plus beta whole square equals to alpha square plus beta square, you are absolutely incorrect. I have also mentioned it in the starting of this video as well. Then you are misplacing this to alpha beta. So to get this value will be equals to alpha plus beta whole square minus 2 alpha beta, and our equation will become alpha plus beta whole square minus 2 alpha beta upon alpha beta. From this equation, we can easily get the values of alpha plus beta and alpha beta that we are going to solve it. So the equation says that 6x square plus 11x minus 10. From this we got the value of alpha plus beta as minus 11 by 6 and alpha beta as minus 10 by alpha plus beta by 10 by 6. On putting this value in this equation, we got minus 11 by 6 whole square minus 2 11 10 by 6 upon minus 10 by 6. 11 square is 121 and 6 square is 36 minus 10, 20 by 6. On taking this upon minus 10 by 6. On solving this, I'm solving this expression on another sheet, and we got 121 upon 36 minus 20 by 6 upon minus 10 by 6. So on taking this LCM, will multiply 6 both side, and we got minus 21 by 6 minus 120 upon 36 upon minus 10 by 6. 121 minus 120 upon 36 is 1 by 36 upon minus 10 by 6. And you know how to solve this double fraction till now, I'm sure about it. 1 by 36, what we'll do, we'll reciprocal this denominator. Minus 6 upon 10. On solving it, 6 1 6 6 6 36, we got minus 1 upon 60. That's the answer for this question. I hope you understand it. Let me give you a short recap for this question, as it was a lengthier one. We were asked to find alpha upon beta plus beta upon alpha. So what we did was, we took the LCM, and when alpha is multiplied on left hand side, it become alpha square, and beta on the same with right hand side, it become beta square. And to find this value, we go through this equation, that is alpha plus beta whole square, and we got the value of alpha square plus beta square, which is equals to alpha plus beta whole square minus 2 alpha beta, and we'll substitute this value in place of alpha plus beta whole square and got this expression here. and then we simply find out the sum of the zeros of polynomial, and the polynomial expression is already given, and the product of the zeros of the polynomial, and put the value in the equation. We got this expression and solve it, and the answer we got is minus 1 by 60. Let's continue with another question. Now the next two questions, we have the type of finding the zeros of polynomial and verifying the relationship with the zeros and the coefficient of the polynomial. So the first question of this type, the question is find the zeros of quadratic polynomial. The polynomial is x square minus 15, and we are asked to verify the relationship between zeros and the coefficient of the polynomial. So it's basically a two-step, or I could say a three-step question. First, we have to find the zeros, then we have to verify the relationship with its sum of zeros, and then the product of zeros. So let's begin solving it. First, we are finding the zeros of the polynomial. The polynomial is x square minus 15, and here we can use the identity as x square minus y square as x minus y and x plus y, and we got here, or you could use it, solve it another way, and I'll tell you both the ways. For this x square minus 15, you got x minus root 15 and x plus root 15. The another way of solving is equate x square equals to 15 and resolving the root, and you got, on resolving the root anything, we get the value of plus minus. So the two zeros of this equation is alpha is equals to minus 15 and beta is equals to plus 15. Now we are asked to verify the relationship. So first of all, we'll find alpha plus beta from our alpha and beta, the exact values we have. So plus root 15 minus root 15 is 0. Now we'll verify this relation with our relationship of alpha plus beta is equals to minus b by a. And what we can see in this equation, there is no value for b. The value of b is 0. So it's simply 0. Hence this relationship has been verified. Now let's come to product of zeros, that is alpha and beta. So on product we got 15, sorry, root 15 into minus root 15, which is equals to minus 15. Okay. On verifying this relationship from alpha beta is equals to c by a, and from this polynomial, quadratic polynomial, we can easily see the value of c is minus 15 and the value of a is 1, and both of these values are equal with each other. Hence this has been verified. Hence verified. Now let's solve another question of the same type. I want you to solve it first and then replay the video and see the solution if you were right or wrong. So the question, the quadratic polynomial. So here the quadratic polynomial given to us is 4x square plus 4x minus 3. Okay, and we'll find the zeros of these polynomial by middle term splitting method. If we could, let's check it. 4 into 3 is 12, and we need to find some value whose product is 12 and sum is 4. So I get it, 6 into 2 is 12 and 6 minus 2 is 4. Okay, so I simply solve it by middle term splitting. We took 4x common, sorry, 2x. You get 2x plus 3 minus 1 common, again 2x plus 3. We got 2x plus 3 and 2x minus 1. So the zeros are minus 3 by 2, alpha is equals to minus 3 by 2, and beta is equals to 1 by 2. Okay, now verifying this relationship. First of all, let's begin with alpha plus beta. Minus 3 by 2 plus 1 by 2. We got minus 2 by 2 is equals to minus 1. On verifying it, alpha plus beta is equals to minus b by a. So minus b, from this equation we got minus 4, and a is equals to 4. We got minus 4 upon 4, which is on solving it, it becomes minus 1. Hence, this relationship has been verified. Now, let's solve it for product of zeros. So, alpha beta is equals to root 3, sorry, 1 minus 3 upon 2 into 1 by 2, we got minus 3 by 4. On solving it with this relationship, alpha beta is 6 by A. So, alpha beta is C by A. Sorry, alpha beta is C by A. What the value of C from this equation is minus 3 and the value of A is 4. Hence, this has been verified. I hope you understand this question. This is a very easy type of questions and a mark gaining question. You have to simplify the zeros, then verify the sum with actual adding it, and by the relationship sum of zeros is equals to minus b by a, and the next step is by actually multiplying both the zeros and then verifying is by the relation is alpha into beta is c by a. That's it. One more question of the same type appeared in last year board examination. So let's solve this question as well. So again, we are asked to find the zeros of the polynomial, and the polynomial is t square plus 4 root 3t minus 15, and to verify the relationship with zeros and the coefficient of the polynomial. So let's begin. The polynomial is given to us as t square plus 4 root 3 t minus 15. So now we have to split the middle term with something. The product should be 15, and on adding it or either subtracting it, we got this value. So 5 could be breakdown as, sorry, 15 could be breakdown as 5 into 3 is 15. So what we can do is we can simply t square plus 5 root 3 minus root 3, on multiplying it we can get 15 minus t. So on taking t common, we got t plus 5 root 3 and here on taking root 3 common, we got 3, and this 5 could be split as 5 root 3 into 3, and I took root 3 common, so I got plus 5 root 3. Now my zeros are t plus 5 root 3 and t minus root 3. So I assume alpha is minus 5 root 3 and beta as plus root 3. Okay, now we'll verify its relationship with actual adding it and by the relationship we know. So alpha plus beta, first of all, minus 5 root 3 plus root 3, I got minus 5, and here we'll assume if nothing is there, we'll assume it is as a 1. So what I got is minus 4 by root 3. Now taking the actual relationship, alpha plus beta is equals to minus b by a. So from this equation, what is the value of b is 4 by 3 and the value of a is 1. So which is equals to minus 4 by 3, and this relationship has been verified. Now let's go with the product of the zeros. Product of the zeros we have given is minus, we have find out is minus 5 root 3 into root 3, which is equals to 5 minus 5 root 3 into root 3 is 3. We got minus 15. On verifying this relationship by alpha beta is equals to c by a, we got minus 15 from this. Here the value of c is minus 15 and the value of a is 1, that is minus 15. Hence it's been verified. We are left with two more questions which are of the type we have already been solved, but that type of question is, I think, is a bit tricky and you need more attention towards it. So I am solving those two questions as well for you, so stay tuned with the end of the video. So this is the next question we are going to solve it. This question says that if alpha and beta are the zeros of polynomial, the polynomial is x square plus x minus 2, and we are asked to find the value of alpha upon beta plus beta upon alpha. So what we'll do, first of all, we'll resolve this On taking LCM, it become alpha square plus beta square upon alpha beta. And to solve this, we have to solve the numerator part of the equation. We have to look towards the identity, that is alpha plus beta whole square, which is equals to alpha square plus beta square plus 2 alpha beta. And from this, we can find the value of alpha square plus beta square by alpha plus beta whole square minus 2 alpha beta, which is equals to alpha square plus beta square. Now substituting this value here in the equation becomes alpha plus beta whole square minus alpha beta upon alpha beta. And we can easily find the value of alpha plus beta and alpha beta from this equation, from the polynomial givens. X square plus x minus 2. From this, alpha plus beta, which is equals to minus b by a, can be get as minus 1, and alpha beta, which is c by a, which is equals to minus 2. And now substituting these value here in the equation, we got alpha plus beta, that is minus 1 whole square minus 2 into minus 2 upon minus 2. We got 1 minus 4, sorry, plus 4. The minus and minus become plus upon minus 2, become 5 minus 5 by 2. The minus 5 by 2 is equals to alpha upon beta plus beta upon alpha. So here comes the last question for this video. It was the last question for this video lecture, and we have solved all the questions that had in the board examination paper for the session 23-24 for the chapter polynomial. And one more reminder for you that these were the questions from standard mathematics paper. Thank you so much for watching the video till the end. Stay tuned and subscribe channel for